Good morning. Hello everyone. This class I will be discussing parallelogram law of vectors with you. What is parallelogram law? Let us try to understand. Triangle law, I assume that all of you remember what is triangle law of addition of two vectors. In parallelogram law of addition of two vectors, we need to start the vectors from the same origin. Okay, suppose there be two vectors A and B represented by this line segment OL. Take arrow always at the end of the vector. Even I do mistake sometimes, I put the arrow here and there, but that is not justified. This is the origin. Vector A is given by OL. And take another vector OM. This is vector B. They are starting from the same point. Now what we will do, we will find the resultant by completing the parallelogram. The law states that if we complete the parallelogram, this parallelogram is OLRM now. These two opposite sides are equal and they have the same direction. These two also parallel and they have the same direction. Then the parallelogram law states that the diagonal of the parallelogram will represent the sum of the two vectors. That R is going to be A vector plus B vector. Now this resultant vector has magnitude and direction both. How to calculate the magnitude and direction of the resultant, that I am going to discuss with you. You assume that angle between two vectors be equal to theta and this one be alpha. Okay, we can find the length of this vector, the resultant, by completing a triangle over there which is going to be a right angle triangle. We have produced a vector OL. Draw perpendicular from R, this perpendicular be Rn. Now if this one theta and this is vector B, it's quite obvious that this one is also going to be vector B. And this angle is also equal to theta. So now we can find the resultant vector OR, that is R. This OR vector will represent the vector R. So in triangle ONR, what do you observe? This is 90 degree. OR square is ON square plus NR square. What is ON over there? OL plus ln whole square plus NR square. Therefore, OR square going to be OL square twice OL into ln square plus NR square. This OL has length A. Vector without arrow is the magnitude. So OL square, this plus, what will happen then? And this OL also A, but ln is what? In this diagram you can see that ln by LR equal to cos theta. So ln equal to LR cos theta. What is the value of LR here? There is B vector B cos theta. So this A into B cos theta we put there. And once more, in this triangle LRN, this is right angle triangle, ln square plus nr square is what? LR square. So this will be A square 2AB cos theta plus B square. So we got the resultant, its value OR or R square. OR vector, its square means here it is R square, OR modulus. So R square is this. So resultant is what? Under root A square plus B square plus 2AB cos theta. Now what's the angle made by the resultant with x-axis? That also we are going to find. The angle made by the vector R with A vector be alpha. Then in triangle LRN, what do you observe? Tan alpha equal to Rn by On. Rn is what? LR cos theta, and On is what? OL plus Ln. Alright. Now what we will do? We will put the values of LR, OL and Ln over there. So LR cos theta, that divided by OL plus Ln is what? That we have already done. Ln is LR cos theta. Wait a minute. Sorry. This part is sin theta. LR sin theta. So this will be sin theta only. And ON plus OL plus Ln. Ln is what? That is LR cos theta. So on simplification, by putting their values, tan alpha going to be LR, that is B cos theta by, my God, 1 second, sorry, B sin theta by A plus B cos theta, or alpha equal to tan inverse B sin theta by A plus B cos theta. So you got resultant formula here, you got angle formula over there. Now this is direct addition of two vectors where forces are involved. This method is very useful. We will find one application definitely, but before that we will be writing what happens when theta equal to 90 degree. For theta equal to 90 degree, R is going to be A square plus B square, because cos 90 is 0, and alpha equal to tan inverse B sin 90, that is 1 by A plus B cos 90 equal to 0, that is tan inverse B by A. Now let us take one application here. Two forces are there, 40 Newton and 20 Newton. They act at an angle theta equal to 120 degree. Find the resultant. So what we will do there, we will be taking those two vectors along two sides of a parallelogram, two adjacent sides. This one 40 Newton and this one 20 Newton. Now complete the parallelogram. This diagonal of the parallelogram, this is 20 means this one also 20 and this is 40. So this diagonal will represent the value. It is 120 degree given, although it doesn't look like that, but assume theta is 120. We have to, I'll give you the actual diagram also, alpha also we have to find. So what will be the resultant here? Find R. R is going to be what? Under root 20 square 2 into 40 into 20 cos 120 degree. $1600, 400, and you know cos 120 is minus half, so this is going to be 2000 minus 800, that is under root 1200. So this is 20 root 3, put the value of root 3 over there, 1.732, this is going to be 34.32 Newton approx. And what is the angle here? Tan alpha will be 20 sin 120, that divided by 40 plus 20 cos 120. 20 into root 3 by 2, and this is 40 into cos 120, 20 cos 120, 20 minus half. So this is 10 root 3 by 40 minus 10, that is 30. Root 3 by 3. So tan alpha is what? Tan alpha 1 by root 3. So alpha equal to 30 degree. Now let us draw the actual diagram. Drawing will be easier here, believe me, in compared to triangle law. But I am not taking that triangle law is a very disadvantageous method. Both are very useful in solving problems. Only area of application may differ. When vectors are starting from the same point, then you apply the parallelogram law. But if you want to add two vectors sequentially, one after the other, you go for using the triangle law. Okay, let us solve this problem with actual diagram. 40 Newton here. This is 20 Newton. This angle we found. How much? 30 degree. And this one is what? 90 degree. Because 120 degree is the total angle. So resultant is 34.32 Newton, and it makes an angle 30 degree with 40 Newton force. Hope you have understood the parallelogram law. Now this is the time to compare those two laws, comparison of triangle law and parallelogram law, which I have already told you. That for triangle law, sequentially two vectors added to get the resultant. How? This third vector, again the same mistake I did there. Vector arrow you never put in between, this will be at the terminated point. If two vectors A and B are there, you are adding them sequentially, then you go by triangle law. But if there are two vectors starting from the same origin, this is A vector and this one B vector, then you go by parallelogram law of addition of two vectors. Okay? This is the resultant of two vectors A and B. Formula already I have given. Clear? Now this triangle law and vector law can be better understood if I take one example like this, where there is a river is flowing with the current velocity. River current velocity is 3 meter per second, V current is 3 meter per second, and a boatman wishes to cross the river straight across. At least he is steering the boat in this manner, in this direction. But river current will take him down. This is the velocity of boat. Velocity of boat directed this way, river current velocity this way. Question is, how to add these two vectors to get the resultant velocity of the boat? If you go by triangle law, what will you get? By triangle law, if you want to add, you take the vector VB here, VC you take here, 3 meter per second. Second one you take here, okay? Or if you see that I will be taking this first one in the form that is velocity of boat, because we are going to add which two? We are going to add VB and VC. So you take VB this way, and then VC will be started from the tip, okay? And then the third side of this triangle will represent the resultant. This is VR, resultant velocity of the boat. You can get it by using the formula for triangle law. Formula will remain the same, that VR equal to root over VB square plus VC square. This time, what's the angle between two vectors? This angle they have given 90 degree. So actual diagram will be like this: VB this way, VC this way. This angle is 90 degree. You find the resultant here. Alright? Find the resultant. This is VB. This is VC. So we are going to be under root VB square plus VC square. This VB modulus is 4 given. So if we go by this, then it will be 4 square plus 3 square, that is 5. And the angle made by resultant velocity with the VB vector tan alpha equal to what? That is VC by VB. So that VC is what? 3. That by 4, alpha will be approximately 37. Okay. The same problem if you do by parallelogram law of addition, by parallelogram law of addition of two vectors, then you take VB this way. This is the real scenario, because you are driving the boat right across the river. So straightforward you go for completing the parallelogram. Sorry. So this time this is a resultant, and its value VR square by formula 3 square plus 4 square, straightforward formula, 2 into 3 into 4 cos 90, that is 25. So VR equal to 5, and this angle alpha will be what? Tan alpha cube sin theta. VB you have taken 4 and this one 3. So 4 sin 90 by 3 plus 4 cos 90. But this time the angle we have taken with alpha, with the vector VC. Here we found it in terms of VB. That also you can find. This time beta. So okay, I am doing tan beta also. This is 4 by 3. So alpha is 53 degree approximately. Therefore, beta will be how much? 90 minus 53. This is 37 degree. Okay. So, both triangle law and parallelogram law will give you the same result. Only the case when sequential addition is required, you use triangle law. And if two vectors starting from the same point, then you apply parallelogram law. Another thing I would like to say, addition of 3 or more vectors will be easier to understand with the help of triangle law. With parallelogram law, you can find, but it becomes bit complicated. Okay, that we'll discuss in another session. Right now, after remembering triangle law and doing parallelogram law, I would like to tell you one method where a vector can be resolved into its components. Okay, what is that? This is resolution of a vector, or resolve parts of a vector. Suppose there are two vectors this way. This is vector A and this is vector B. You are adding these two vectors, that is A plus B. What will you get? You use triangle law or parallelogram law, you get this thing, a vector C, which is equal to the vector sum of these two vectors. So you have added two vectors here. This is addition of two vectors. You have done it by triangle law, parallelogram law, there is no difference. Now if you want to get back two vectors from the vector C, then this is going to be A plus B, or you write the vector, you draw the vectors, vector A and vector B. Okay, so this method is called resolution of vector. Here we have done addition of two vectors and here you have done resolution. Okay, vector we have resolved into its components. What are those components? See, A and B making the vector C. This time from the vector C you are getting the vector A and B back. That's why it is called resolution. This was addition and this is resolution. Now, if any vector is there in 2D, you take a vector A, okay? Two vectors A and B also there, but it is better to take those two vectors as two components here. I am showing you that vector we have taken the resultant as the vector C, that I am showing you in diagram. Let us do it by parallelogram law. This is vector A, this one vector B, and the resultant you got by the use of parallelogram rule, that is this is OA, OB, and this is C. Okay, this C vector here in this diagram, OA is A vector, OB is B vector, then OC is what? OC is C vector, that is A plus B. Now, suppose the angle between two vectors known, where that angle theta we are taking this one as alpha, this one as beta. Okay, beta. What are the values of this A and B? B is there also. what are the values of magnitude of A and B in terms of the vector C and the total angle theta equal to alpha plus beta, that we are going to state. See, in this parallelogram, if this one alpha, this one beta, this has to be equal to beta. So what about this one? This will be 180 minus alpha plus beta. You use the sine rule of triangles. What is that? Using sine rule, what do you have? That this magnitude is C only, C by sine 180 minus alpha plus beta, this is equal to A by sine beta, B by sine alpha. This is triangle law. Length of side divided by opposite angle, length of side divided by opposite angle, length of side divided by opposite angle. Therefore, C by sine alpha plus beta equal to A by sine beta, beta not B, B by sine alpha. C is the resultant. Here you just compare these two. The vector A is coming. This is C sine beta divided by sine alpha plus beta, and B equal to what? C sine alpha divided by, this way you can resolve the vector C into its two components, where C vector makes alpha with A vector and beta with B vectors. Now imagine that theta equal to 90 degree. So this implies alpha plus beta 90 degree. Then A will be equal to what? A will be equal to C sine beta, and B will be what? C sine alpha. Now alpha plus beta 90 degree, change this one. Sine 90 minus alpha, C cos alpha, and this is C sine alpha. And when you have taken the component this manner, you are resolving vector. The vector C you are resolving in two directions. One is horizontal and the other one is vertical, isn't it? Because you have taken this one alpha, this one beta, this is A vector, B vector, and this one was C vector. The value of A you got C cos alpha. This you can write Cx. Value of B is what? C sine alpha. That is Cy. So if a vector C is there, now we will write it has a horizontal component. It has a vertical component. What is the horizontal component? That is Cx equal to C cos alpha, C sin beta. This is the vector C. So these are called resolved parts. These are called components of a vector in 2D and 3D. In 2D we have done. So a vector C can be resolved into its components. Suppose you know this angle only. They will say that horizontal component is C cos alpha, vertical component is Cy equal to C sin alpha. This method is very helpful. When a vector is resolved into its component, we can get the vector back from there, provided the two vectors, the two components are given. One example I tell you. Here you got the vector C by resolving into component. One is Cx, the other one is Cy. And this angle is alpha. You have written Cx equal to C cos alpha, Cy equal to C sin alpha. So you just make squaring and then add Cx square plus, so C will be what? Under root, okay, just squaring and adding. If you add these two, it is coming C square cos square alpha plus sin square alpha, that is going to be 1. And if you divide 2 by 1, what do you get? Cy by Cx equal to tan alpha. So alpha is clear? Hope you have understood. So if components Cx and Cy of a vector known, then we can get the vector and the angle made by the vector with the vectors with horizontal. I just take one numerical example. Two vectors 20 Newton and 20 root 3 Newton are there, two forces. Okay, I mean this is horizontal component. Let two components be of a vector be 20 Newton and 20 root 3 Newton respectively. Find the vector. You just find. So simple. Finding vector means you have to write its magnitude, you have to write the angle made by it with one of the vector. Then it's done. So if you use this formula, that the vector is C, C is going to be what? $40 Newton and 20 Newton you have taken this manner, say 20 root 3 you have taken this manner. These are horizontal and vertical components. This is the resultant 40 you got, this angle be alpha. Then tan alpha is what formula you got? Cy by Cx. Tan alpha 20 root 3 by 20. So alpha equal to 60 degree. Hope you have understood. This way you can find the resultant between two vectors. Sorry, this way you can find the original vector if two components are given. Okay. Now in 3D what will happen? In 3D, a vector is there, coordinate axis x, this one taking z, three mutually perpendicular axes always there, and this is the vector r. Okay. We want to express it in terms of its components. How to? You draw a perpendicular here on the xy plane. If you draw a perpendicular on xy plane, that is going to be along z axis. Okay, and join the base this manner. Now this vector r is what? Suppose the component be rx, ry, rz. So R is what? In this diagram, this is your RZ. You cannot change it. Directed along Z axis. And this we don't know. We will find it. This is in XY plane, no? This vector lies in XY plane. So if it lies in XY plane, that vector will be taking as vector. You always take the arrow sign here at the top. So in triangle OAB, what is going to happen? OB equal to OA plus AB. So R vector equal to OA is what? This is the vector in XY plane. We are taking that as RXY. Okay? And from this one you draw a perpendicular here also. So R vector is going to be what? RXY plus RZ. What is RXY here? RXY, this is component along x-axis and this is along y-axis. RXY is what? That is Rx plus Ry. So you write Rx plus Ry. So if there is a vector 3D, it is made of these three components: component along x-axis, component along y-axis and component along z-axis. Okay? Now a question arises, can we represent all those vectors in 2D and 3D by using the unit vectors? So I am continuing the topic actually, representation of a vector in number 1 2D. How do you represent? There is a vector. You will obviously represent in terms of its components. Components are horizontal component. This vector be R. We want to get component along x-axis and y-axis. Let it be Rx and Ry. Okay, this is along x-axis and this is along y-axis. So this R vector was like this. Now R vector is what? Assume that unit vector along x-axis be I cap, along y-axis be j cap. So in this diagram, R vector is what? Rx plus Ry. This we have discussed. Now Rx vector is what? That magnitude into I cap. Ry vector is what? The magnitude into j cap. In details I have explained this in previous videos. So this will be Rx I cap, Ry j cap. This is representation of vector in 2D. Now assume that this strip has coordinate x, y. Okay. So how do you do that? Then from here you draw the perpendicular on x-axis. I am going to do that coordinatization of the vector. If the tip has the coordinate xy, then can't I write this Rx equal to x into I cap, this Ry equal to y into j cap. So R vector going to be xi plus yj. This is representation in 2D. Molar is what? Length of the vector. This is molar, no? Length of this side is molar. It is by Pythagoras theorem x square plus y square. Hope you understand. So we write mod of xi plus yj equal to under root x square plus y square. Clear? In 3D what will happen? In 3D, three-dimensional coordinate system will be there. And the vector can be slid parallel to itself. Anywhere it may be there. But we will be pulling the vector to start from the point O, the origin. This is the vector R. X, Y, sorry, this one we have taken Z, we keep that only. Z and this is Y. Suppose this point has coordinate x, y, z. X is the x component, y is the y component, z is the z component. Okay? So that vector are going to be what? Follow the same method. Draw perpendicular here. Join this. This is R vector. R is what? This part is x, this part is y because along y axis, and this part AP part is z. R equal to what? OA plus AP. This perpendicular, we need not draw this. This perpendicular is AM on x axis. So this OA vector we can write, OA vector is what? OM plus MA. This is OM is what? X I cap, and MA is what? Y j cap. AP is what? That is along z axis. Unit vector in this direction be k cap. Here already I told I cap. So AP vector will be what? OA plus AP. AP is what? AP vector you write. That is z into k cap. Therefore, OP vector will be OA plus AP. OA we found. AP also we found. So the vector are now expressed in terms of the coordinate of the tip. And mod R, we can show that by using this right angle tangent only. It is mod xi Clear? Hope you have understood. Resolution of any vector in 2D, in 3D, and their representation of a vector in 2D and 3D. Now a question arises, what is the advantage of this resolution method? This resolution method will help you to add many vectors easily. I just show you one example, one application in 2D. We are going to do application of resolution of vectors in 2D. Imagine that there are many vectors. In 2D there are many vectors. This is your x-axis, y-axis. There is a vector R1. It is making an angle theta 1. There is a vector R2. This is making an angle theta 2, and this way many vectors are there. One vector R3, it is making theta 3 with x-axis. Another one, say Rn, it is making the angle theta n, say, with x-axis. You have to add these n vectors R1, R2, R3. These n vectors you have to add. See, triangle law, parallelogram law, both will be not very useful to find the sum of these n vectors. N is not 2 or not 3, it is many. So how to add that? What we will do here, you will find the component of each vector along coordinate axis. Let me write the vector R1 in terms of its component. It is R1x plus R1y. What is R1x? R1 cos theta 1 I cap. If you write this, it is R1x I cap plus R1y j cap, R1 sin theta 1 j cap. This is number 1. We have written R1 vector in terms of component, which we have discussed in this class. What is R2 vector here? Cos theta 2 I cap sin theta 2 j cap. This is number 2. R3 and the last one, that is the nth vector. This you write all. Rn vector is what? Rn cos theta n I cap, Rn sin theta n j cap. Agree or not? I have written all the vectors in terms of their components. Now, you got components only. Replace all the vectors by two vectors only, because those are components along x and y axis only. You add all these vectors. Simple algebraic addition. That R vector, which is resultant of R1, R2 up to Rn, this manner, it is actually the sum of those. You add the components of I together. This is R1 cos theta 1 plus R2 cos theta 2 Rn cos theta n I cap. This plus R1 sin theta 1 R2 sin theta 2 Rn sin theta n j cap. Isn't it? But these components you have added, no, you just write this one as Rx, sum of the components. And some of these components you write Ry, because they are all along y-axis. So you have Rx over there, you have Ry over there. All the vectors replaced by these two components only. So resultant vector we can write Rx I cap, Ry j cap. What is mod R over there? This will be Rx square plus Ry square, isn't it? And what is the angle made by Rx, resultant with x-axis? This alpha we have seen, if the angle is 90 degree, we have taken rectangular components. Tan alpha will be what? Ry by Rx. So alpha equal to tan inverse Ry by Rx. Let us take one practical example here. I am taking three vectors this manner. One vector is a force 40 root 2 Newton acting at an angle 45 degree. One vector along y-axis only. Okay, take another one along x-axis also, 30 Newton. This is 40 Newton. The second vector is 80 Newton, making an angle 135 degree. This is first, second, third, fourth, fifth one also there. Fifth one making an angle 415 degree. No, sorry. This is 315 degree. And its value is given by, say, 120 root 2 Newton. This one you take 80 root 2 Newton. Okay? Because of better calculation. How to add all these vectors? How many vectors are there? 1, 2, 3, 4, 5. What is the method I have told you? You always take some of the components along x-axis. Rx going to be what? This 30 Newton already there. 40 root 2 cos 45. 40 cos 90. 80 root 2 cos 135 degree plus 120 root 2 cos 315 degree. Hope you have understood. This is actually 30 cos 0, no? If you write. So this is 30, 40, this is 0, this is 80 root 2 minus 1 by root 2. So minus 80. This is 120 root 2 1 by root 2, because cos 135 degree you know minus 1 by root 2. Cos 315 degree fourth quadrant, it will be 1 by root 2. So Rx going to be what? 160 plus 30 or 90, that is 110 Newton. Similarly, you find Ry. Ry will be what? 30 Newton component, it will be 30 what? 30 Newtons component along y-axis. 30 Newtons component along y-axis will be 0. Isn't it? We are resolving all the forces along x-axis first and then along y-axis. Okay? 30 Newton, the horizontal component we got. Vertical component will be what? Because it makes 0 degree with x-axis. 30 sine 0 plus 40 root 2 sine 45, then 40 sine 90 then 80 root 2 sine 135 degree. Sine, isn't it? This is 0, this is 40, 40, this is 1 by root 2, 80, and this is minus 1 by root 2. Sine 315 degree is okay. So this will be minus sine, that is minus 1 by root 2. If you put it there, this is going to be minus 120. So this is nothing but 40 Newton only. Now you have two vectors only, that Rx is there, sum of all the components. Rx is 110 Newton. What is Ry? Ry is going to be 40 Newton. So resultant going to be what? Eleven square, no? Root 10 into 121 plus 16, that is 137 Newton, and the angle made by resultant with x-axis you can get by this formula. Tan alpha is 40 by, so alpha is hope you have understood the concept of resolution. You need to practice sums based on it to get good control on it.